Hello, and welcome to one of 8 short videos from Skills for STEM. Each video is designed to supplement your CIOB Chartered Membership Programme workbooks. These videos should be studied in conjunction with each of the 4 modules, and you should also undertake further reading on the topics introduced. This will help to improve your overall knowledge. The videos will also introduce some useful websites which you can refer to help you gain a better understanding of the subjects. Feel free to stop and start the videos and to make notes in the margins of your workbooks to help you. If you are unsure of a topic, you could always watch the video again to help your learning. Good luck in your pursuit of Chartered Construction Manager. Module 2, Construction Management, Part 2. In the previous session, we looked at the management of resources in the construction industry, specifically personnel and plant and equipment. Now let's move on to project finance and subcontractors. Central to the success of any construction business is its ability to manage its cash flow. This entails the planning, funds use, monitoring of budget implementation, and evaluation of the results. These are all essential stages in project finance to ensure that money flows from the client to the contractors smoothly. If cash flow is not properly managed, organisations run the risk of being unable to pay their operatives or purchase the materials required in order to be able to complete the project on time and to budget. There are 3 areas on which the cash fund managers should focus. 1. Planning for the use of funds, with the budget plan being strictly implemented. 2. The cash flow status report, which provides the summary of cash in and out of the business. 3. The company's financial statement, which shows that the process of managing cash flow is as planned. If there is an imbalance between the money coming into the business and the money being spent on resources, organisations can find themselves on what is called the cash flow roundabout. If there is an imbalance between the money coming into the business and the money being spent on resources, organisations can find themselves on what is called the cash flow roundabout. In simple terms, there needs to be sufficient money in the organisation to allow contractors to pay suppliers and subcontractors and still have some money left in order to cover the day-to-day running of the business. They should also have some surplus money in case of unforeseen expenses. These additional funds are often referred to as contingency. Cash flow is also an issue for the construction supply chain and is a common reason for the contractors and subcontractors becoming insolvent. This could be catastrophic for a project in terms of its time and money. It is the client's best interest, therefore, to ensure that the supply chain is paid promptly. The government suggests that historically this has not been the case, and it has not been unusual for supply chain members to have to wait up to 100 days to receive payment. This in turn damages their cash flow and can harm their business. Led by Professor Rudy Klein, the Specialist Engineering Contractors Group lobbied hard for the introduction of project bank accounts. Project bank accounts, or PBAs, enable faster payments through the construction supply chain, with payments being made as soon as 5 days from the due date. This is intended to reduce customer problems that can lead to supply chain members becoming insolvent. In September 2009, the Government Construction Board proposed that the government projects should begin to adopt project bank accounts unless there was a compelling reason not to do so. In 2011, the government set a target for £4 billion worth of contracts to be issued using project bank accounts by the end of 2013-14. In 2014, Francis Maude, the then Minister for the Cabinet Office, announced that £5.2 billion worth of government construction projects were being paid to project bank accounts, including projects such as Crossrail. In 2016, the Scottish Government adopted project bank accounts for all its building projects with a value of more than £4 million. and the Welsh Government announced that it would use project bank accounts for buildings over 2 million with effect from the 1st of January 2018. Here's a short video by Fred Mills which explains what project bank accounts are in more detail.
Historically, the construction industry has been pretty bad at paying people, with those at the lower end of the supply chain sometimes having to wait up to 100 days for payment, damaging their cash flow and their business. Project bank accounts are all about changing that. They are a central, ring-fenced bank account created specifically for a project. The client puts their funds for the project into this account and then pays the members of the supply chain directly and simultaneously from there. Project bank accounts have trust status. This means that the funds in them are secured and can only be paid to the beneficiaries, the supply chain members who are named on the account. The advantage of trust status is that, in cases of insolvency, the monies in the account due for payment to the supply chain are secured and can only be paid to them. You can use project bank accounts on schemes of any value, and a number of banks around the world now offer this service. Several forms of contract have also incorporated provisions for PBA arrangements. This approach means that firms in the construction supply chain, many of whom are small or medium-sized businesses, receive payments in 5 days or less from the due date. It addresses unfair payment practices, ensures transparency and certainty of payment, reduces the need for borrowing, and creates a more balanced trading environment, supporting growth. It means the supply chain can focus on the task in hand and no longer have to waste time chasing payments or financing very long credit periods. Project bank accounts can eliminate payment disputes and the costs associated with them, which ultimately feed back into costs for the client. They improve trust across the board, leading to increased levels of collaboration. Several projects in the UK have already been delivered with project bank accounts to date. Of course, this is quite an upset to the established status quo, and it's not been met universally with open arms. Project bank accounts are just one part of changing the construction industry for the better, and they'll become easier to implement once the other pieces of the puzzle are there too. Once we're trading with each other on value rather than cost. Once we're investing in our built environment and the data that supports it rather than trying to construct it as quickly and cheaply as possible. Once we're partnering with each other to deliver a shared objective rather than drawing the battle lines in our contracts. You can find out more about project bank accounts at this link. If you found this video useful, don't forget to share it with a friend and subscribe to the B1M to get others just like it.
In order to properly monitor the cash flow of a construction project, it is important to receive regular cash flow status reports. These will highlight current cash positions of the projects involved and should include the total costs, billings, payable, this is money that is due but has not been paid yet, receivable, this is money that has been billed but has not yet been received. Since a large contractor may have several projects going on at the same time, it would be necessary to bring all of the cash flow project data together under one current cash flow position for the organisation as a whole. This overview is important since some projects may be running over budget and others running under budget, such that the total cash flow and financial position of the organisation could be balanced and therefore sound. Moving on to the last item in this section, the management of subcontractors. Subcontractors can serve a number of useful purposes, reducing the overall need for labour employed by the main contractor. They can also provide specialist services such as lift and escalator expertise or groundworks, for example, which a main contractor would not normally be able to keep fully occupied. They can also help in managing peaks and troughs in the requirements of resources during the different phases of the project. It should always be remembered that a subcontractor working on your site will be seen by the casual onlooker as your operatives. It is therefore essential that they are capable of carrying out work to a satisfactory standard in a safe and professional manner. As a result of this, subcontractor selection has become a very important part of any construction project. These issues may have a financial impact on your project, which will also lead to reputational damage, which is much harder to recover from. It is therefore recommended that the recruitment of subcontractors is treated in the same way as you would treat recruitment of any other employee. To try to protect reputations, the construction industry has increased the demand on subcontractors to supply information about their projects that they have worked on, their financial viability, the competence of their workforce, their health and safety record, and a whole series of other pieces of information. The downside of this for the subcontractor is the time taken to complete these questionnaires, since each document can require different information in different formats. In order to try and alleviate the pressure on subcontractors to complete a number of different forms of inquiry, publicly available specification PAS 91 was developed. This document sets out a set of standard pre-qualification questions which the government and the vast majority of large contractors and clients subscribe to. This has drastically reduced the time taken to respond to PQQs, or pre-qualification questionnaires, since once completed they only require a small amount of effort to update them for the next client. The checklist in your workbook outlines what sort of information you should require. It recommends references, insurance, health and safety policies and procedures, industry-specific qualifications and certifications, training records, equal opportunities policies, corporate social responsibility related policies, and proof of financial stability. Some trade associations, such as the Building Engineering Services Association, or BESA, operate a contractor accreditation scheme, where this information is monitored on a regular basis so that potential clients can be confident that the organisation they are seeking to recruit meets the minimum industry standard. Construction project planning is a method of determining what is going to be done, who will be doing it, how long it is likely to take, and when they will actually be carrying out the task. Construction project plans describe sequences of activities, including dates, and they generate all of the tasks in the critical path, i.e., the things that have to be done in sequence and therefore determine the length of the project. They also determine the order in which tasks have to be conducted and any spare time or float which has been included in the project consideration. It is also an opportunity to identify specific resources and account for their lead time. I was involved in a school construction project where the finish for the lift car needed to be specified before the groundworks had even started, due to the extended lead time on the lift itself. Activity schedules, or Gantt charts, named after Henry Gantt, an American engineer, are often used in order to show when each item is required. It separates each item of work and includes resources and materials so that they are available at the correct time. New developments mean that Gantt charts can be linked to the BIM model. This is often referred to as 4D BIM. Here's Fred again.
So, what on earth do people mean when they say 4D BIM? Well, it's a process that can add a lot of value to design and construction, saving both time and money. As you create an information model, you can add scheduling data to different components, generating accurate program information and enabling step-by-step visuals of your project's development. It's this process that is known as 4D BIM. 4D BIM involves time-related information being associated to different components of an information model. For a specific element or work area, that could include details on its lead time, construction and installation period, curing and drying allowances, sequencing, or its interdependencies with other areas. With this data included, planners can quickly develop accurate programs for projects based on one reliable source of federated information. The specific activities and items within those programs can be clearly linked to their graphical representations. The inclusion of time-related attribute data also enables 3D visuals of a project's development to be created, showing how it will be constructed and how both the structure and sites surrounding it will appear at each stage. This is hugely beneficial in terms of planning work in a safe and logical way that maximises efficiency on site. With program and visual information like this to hand, project teams can effectively prototype assets in a virtual environment first and provide rapid feedback on design or methodology changes to their colleagues. Such an approach helps to negate last-minute on-site design coordination and rework, ultimately eliminating waste from the delivery process and speeding it up. This is key as construction sites are expensive to run and represent a significant proportion of the total cost on many projects. The efficiency generated can streamline the cost base for project teams and increase their capacity, whilst reducing overall delivery costs for clients. 4D BIM is also a powerful tool for communicating the impact of built assets with local stakeholders, both during delivery and once completed. Everyone can see and comprehend a clear impression of how the asset will appear, rather than having to envisage that from plans or Gantt charts. You can work with 4D at any stage of a project, and indeed it can add a lot of value and influence at the front end when assessing the feasibility of schemes. It's also really useful during tendering if you want to get a very quick handle on a project, or to demonstrate and build confidence around your methodology as part of the selection process. Clearly, the information you'll gain from the process will be quite high level in the early stages and will build in detail as the project progresses. One important point to note is that 4D BIM refers to a particular way of linking data to an information model, an additional dimension of data. It's quite different to the BIM maturity levels that run from 0 to 3 and beyond, describing the supply chain's ability to exchange information in a digital way. 4D, 5D and 6D considerations can all occur within BIM Level 2. If you're working with 4D BIM, it would be wrong to say that you're working at BIM Level 4.
It is also possible to include costing into the BIM model. Known as 5D BIM, this addition supports the cost manager as explained here by Trevor.
For cost managers, BIM is transformational. Instead of quantity spheres or cost managers having to manually extract quantities or measure quantities from drawings or schematics or single line diagrams, they can automatically extract quantities from building information models. It's what we call 5D BIM, where we've taken the three-dimensional model, we've appended cost information to it, and rapidly produced estimates. The big change for quantity spheres is we're now free to do higher value added work, as in validating the information in the model, verifying that scope has actually been trapped in the model itself, and supplementing the quantities extracted from the model with items which may not necessarily have been modelled. As a cost manager, you need to deploy and adopt BIM and BIM methodologies because other members of the design team are using BIM to create designs and model construction projects. And the rate of change and the ability for designers to iterate through design options without having the additional overhead of changing schedules and plans and sections and elevations manually means that changes are going to come thick and fast at cost managers. We simply have to embrace BIM. Manual methods of measuring and counting are just too slow. Currently, we tend to cost completed designs. We don't help designers design to cost. And that will be the opportunity and the challenge for cost managers to allow us really help the design team design to cost.
Finally, in the world of project planning, it is possible to take into consideration the whole operational cycle of the building post-construction. This final enhancement to the BIM model is known as 6D BIM, and again, here is a short explanation from Fred.
Working in construction, it's easy to get caught up in the process of designing, pricing and delivering buildings, and to forget that those buildings are then around for many decades afterwards, having a pretty big influence on how we live our lives and run our businesses. In this video, we're going to look at 6D BIM and the value it can bring. Taking it one step further and adding information on the expected lifespan and maintenance requirements of a component to support facilities management is what we call 6D BIM. That data can include details about the component's manufacturer, when it was installed, the necessary maintenance that it requires and when, how to operate it at its optimum level to enhance performance or conserve energy, and its expected lifespan. Just as an aside, it's important to note that 6D BIM refers to a particular way of linking data to an information model, an additional dimension, if you like, of data. Once collated and linked into the information model, that 6D data can be used to support decision making during the design process and to support the operation of the built asset once it's in use. Let's take a quick look at both of those applications. Firstly, let's look at how 6D data can support the design and delivery phase of a built asset. At design stage, 6D information enables teams to consider the impact of their proposals over the building's life cycle, simulating their anticipated outcomes and costs. In that all-consuming delivery phase we spoke about at the outset, it helps switch the focus from capital costs onto the whole life operating cost of the asset. The earlier you can do this in a project, the greater the value it will add. Ideally, you'd do it right from inception. That value is realised in supporting the operation of built assets once they're in use. At handover, the project team will be able to pass this complete data set, now known as an asset information model, over to the building's end user. The digital model provides them with a more controlled, accessible and easily navigable way of managing their information. It's much more practical than the bundles of lever arch folders that are handed over traditionally. We'll take a look at how you can hand over a digital model to an end user in a different video. With data on maintenance, lifespans and energy performance to hand, building operators can determine the costs of these activities and create spend profiles over a building's life, pre-planning maintenance activities years in advance. It helps them adopt a completely planned and proactive approach to facilities management, as opposed to a reactive one, when unexpected events and costs can crop up at any moment. Where maintenance does occur, or where an asset is extended, refurbished or remodelled, operators can update the information model with the relevant points about that event. Having this available is especially powerful when creating similar built assets in the future. It enables design teams to hone proposals accordingly based on real, in-use data. And in construction terms, that's kind of the holy grail. That data will enable us to deliver better buildings and to support numerous other industries that all contribute to our economy and our way of life. That's when people will understand the importance of construction and give it the respect that our industry so badly deserves.
It is important to note, as Fred said, that 4, 5 and 6D BIM are additions to the BIM Level 3 or 2 model and are not levels in their own right. That is to say, if you are using these additions, you are not working at BIM Level 4, Level 5 or Level 6. I think you can see that the introduction of BIM will mean that projects are less of a one-off, but they still require the coming together of project teams in unique circumstances, which may never be repeated. The complexity of projects means that there are plenty of opportunities for delays to occur. In 2001, the National Audit Office found that 70% of government projects were late. Hopefully, the correct implementation of BIM will assist in improving product delivery times. Try to consider all of these factors as you work through the scenario of the oligarch's fantasy house in your workbook. Performance management in the construction industry has been spoken about at length for many years. It could be considered an integral part of performance management, and the old adage, if you can't measure it, then you can't manage it, is often applied. It is therefore important that key performance indicators or KPIs are established early on in the project to assist the management process. There are a few systems that are applied to the construction industry, such as the Government Soft Landings project, originally developed by BISRIA, the BRE-BREEAM program, and the American equivalent LEED, which help to establish some sort of measurement framework. Borrowing heavily from the manufacturing sector, the introduction of the Construction Lean Improvement Program, or CLIP, was developed in 2003 by the Building Research Establishment. This was designed to support the UK construction industry to improve its financial performance, which have been highlighted as poor in the Egan report mentioned in previous modules. It is probably true to say that the vast majority of success for construction projects is built upon the professional ethics of its workforce. In short, professional ethics can be summed up as the ability to do the right thing even when nobody is looking. All professional bodies in the engineering and construction sector have codes of conduct which lay out the expected ethical behaviour of their membership. As a chartered construction manager, you will be expected to subscribe to and adhere to CIOB codes of conduct. Of course, codes of conduct are not a new idea. One of the oldest and perhaps best known is the Hippocratic Oath, still taken today by doctors. The greatest asset the construction industry has is its people. Performance management is a process by which managers and employees work together to plan, monitor, and review employees' work objectives and overall contributions to the organisation. It is therefore important that as a manager, this process is understood and correctly applied. Your organisation will have its own performance management process, which will be job specific, aligned to the organisation's strategic direction, easy to understand and implement, with sufficient time for both parties to fully engage effectively. The Advisory, Conciliation and Arbitration Service, or ACAS, is one of the best providers on guidance with regards to managing performance. Any performance cycle, such as the one shown in this slide, may be familiar to you, and it is the basis on which most performance management programs are conducted. Effective and efficient people working for organisations with a clear set of objectives deliver excellent projects on time and to budget. This concludes Module 2, Part 2.